So we've learned how to predict the charge on a single ion from its position in the periodic table. What would be nice to be able to do would be to be able to predict the formula of the ionic compound that forms between a given metal and non-metal. So I guess what I'm getting at is, how did I know that sodium and chlorine combined to form NaCl? Well, we have a 1-to-1 ratio between the ions, but magnesium combines with 2 chlorines to form MgCl2. Well, we have a 1-to-2 ratio between the ions. How did I know that there would be 2 chlorines in this compound and only 1 chlorine in this compound? So let's just kind of review how we write the formula of an ionic compound. So when you write the formula of an ionic compound, you begin with the metal, followed by the symbol for the non-metal, and you indicate the number of each type of ion using a subscript following the ion's symbol. We don't include any charges when we do this. The charges are omitted, just the element symbols. Okay, so here is MgCl2, and what that's saying is the compound that forms between 1 magnesium ion and 2 Cl- ions. Okay, now you can see here that we don't put the subscript 1 in if there is only one of something. It's understood that there's only one, right? You wouldn't bother writing the symbol for the ion if there wasn't at least one of that ion present. So you'll see that we never actually write in the 1, just like we never write in the charges. Okay, so what happens when an ionic compound forms is electrons are lost by the metal and they are gained by the non-metal, and the electrons just move from the metal to the non-metal. So what that means is that the number of electrons that is lost is always going to be equal to the number of electrons that are gained, because you're just moving electrons from one place to another. So if you start with 2 neutral atoms, that means that the number of protons equals the number of electrons, and then all you do is just move around the electrons, and then you're going to end up in a situation where the number of protons equals the number of electrons, and you're going to have electrical neutrality. So what we're really saying is that positive and negative ions always combine in a ratio that results in electrical neutrality. However many positive charges you have an equal number of negative charges. So how do you determine the ratio that ions are going to combine in order to achieve electrical neutrality? And it turns out that it's pretty easy. The easiest way to do this is what we call the crossover method, where the charge on one ion becomes the subscript on the other. So here we go, Na plus combining with O2 minus, we bring the size of the charge on the oxygen down to the sodium, and the size of the charge of the sodium down onto the oxygen. So this is telling me that I need 2 sodiums and I need 1 oxygen. So here's my formula for the compound. Now, as I mentioned previously, we always write the symbol for the metal on the left, same as the order of the elements in the periodic table, always have the metals on the left. Okay, so the formula should always indicate the simplest ratio of anions to cations. Now, sometimes, not very often, the crossover method doesn't give you this simplest ratio. For example, we might combine lead-4 ions with O2 minus ions, and the crossover rule would give us this. Now you can see here that this is not the simplest ratio, 2-4. We can divide through by the common multiple of 2 and simplify that ratio further so that we recognize that we have a 1-to-2 ratio of lead to oxygen. So that's a little something that you want to be aware of. It doesn't come up very often, but after applying the crossover rule, you should check to see whether you can simplify your formula by dividing through by a common multiple. Now, you don't always need to use the crossover rule. You can leap to the answer if you observe that the cation and anion have equal and opposite charges. If that is the case, then they're always going to combine in a 1-to-1 ratio. So it doesn't matter though, if we did do the crossover rule, we would eventually get to the correct formula because we'd go MgO2 and then we would simplify that, wouldn't we, to MgO by dividing through by the common multiple of 2. But however, if you recognize that your charges are equal and opposite but the same size, then you know that they're just going to combine in a 1-to-1 ratio every time. So Al3 plus and P3 minus, you would know that they're going to combine in a 1-to-1 ratio. Na plus and Cl minus, they're going to combine in a 1-to-1 ratio. But as soon as you see that two ions do not have equal and opposite charges, you also immediately know that they're never going to combine in a 1-to-1 ratio and that you have to do the crossover rule. So it kind of, it's a good little thing to keep in mind. Okay, so we had a good attempt at practicing writing ionic formulas. So given, it doesn't really matter, I'm just making random numbers up now. Given two ions, you should be able to always write the formula that explains how they will combine with one another to form an electrically neutral compound. Okay, hope you found the video helpful.